Right? What we have here is chemistry. So this question falls under nuclear chemistry. Okay, what we have here, if a sample of radioactive material has a half-life of 14 days, what fraction of the original reactive nuclei will remain after 42 days? Now let's look at something here, solution. I keep telling people that chemistry needs understanding of the question asked, okay? And two, it depends on your tutor. The way I handle my class, I make it very simple and very simple. Okay. So now let's read with understanding. And by the way, whenever you have a question like this, the first thing you need to do, you need to draw a table. This table will really help you. So let's look at the question, the table. The table goes this way. It goes this way. Okay, once you have this table, your work will be very, very easy. Okay, so what you should have here is time. Okay, and this time is the half-life. You know the half-life is a time, right? So now what you should have here is a quantity left, quantities left, or you can say remain. Okay, quantity left. Okay, the sentence used here, or sorry, the word used here is remain. So I can choose to say or remain. Okay. So once you have this, let's go back to the question. If a sample of radioactive material has a half-life of 14, this is your half-life. This time is your half-life. So what you should have here is each time or each day. Okay, let's come this way. What you should have here is your half-life, and it is 14. Okay. Now, what you should have here is the quantity left, and that's what they're looking for, the fraction left. You can call it the fraction left or the quantity left. Okay, this other side. Now, they say the half-life is 14. They say the half-life is 14. What fraction of the original radioactive nuclei will remain after 42 days? So, each after 42 days. So, the first thing is you write after 14 days. That is the first one. After 14 days, you have your 1 over 2, which is the fraction. Okay, that's the quantity left after 14 days. And these 14 days, they say, look at the question, they say, what fraction of the original radioactive nuclei will remain after 42? So they are looking for 42 days. So once you have 14 up to the number that it will give you 42, that's where you stop. So now after 14 days, I have my fraction is 1 over 2. Another 14 days, okay, you have another 14 days. After another 14 days, you have another fraction. Okay, is it up to 42 days? No, because if you check this is 28. It's not up to 14. Sorry, it's not up to 42 as required here. So you go again after 14 days. After 14 days, you have another fraction 1 over 2. Okay, you have another fraction. So sum all this. Is it up to 42 days? Actually, yes, it's up to 42. So you can then say, if you sum the whole of these things, if you sum the whole of this, it will discover that this is 42 days. That's 42 days. So once you have your 42 days, stop there. All right? So you can now say, therefore, the fraction, they say, what fraction of the original? So the fraction remain after 42 days. After 42 days is what? Is equal to, okay, is equal to, now you have the first fraction, which is 1 over 2, times another 1 over 2, times the last one, 1 over 2. So this will give you 1 over 8. So this is a fraction left after 42 days. Do you understand the work? It's very simple, right? So chemistry is not hard, but look for a tutor that can break down chemistry for you. Thank you for watching. So you can subscribe to my YouTube channel and then share the video. You can learn more